Hello, ladies and students. Today we're going to look at solving systems using matrix equations and inverses. So this is just another tool to solve systems of linear equations. Your learning goal: I can solve a system of linear equations using matrix inverses. So first things first, we got to learn how to make a matrix equation. So basically a linear system can be written as a matrix equation: AX equals B. So I have this really awesome system right here, and I can rewrite. So you're going to write your coefficient matrix. We already made a coefficient matrix before, right? That's the numbers in front of the x and the y when we were making our using Cramer's rule, right? Then x and y is going to be your variable matrix. So basically, if I would multiply these two together, I would get this back out. And then 8 and 6 is your constant matrix, or you could even call that your answer matrix if you want to call it that way. So we need to be able to write these as matrix equations. That's the very first step. So here I have this beautiful matrix, or this beautiful system. Let's write it as a matrix equation. So I'm going to first write my coefficient matrix: -3, 4, 2, -1. Then I have the xy matrix, your variable, equals my constant matrix. Not too bad, right? Just writing them, but that's the very first step to being able to solve them, is you got to be able to write them in matrices. So, how are you going to solve? So, suppose I have A times X equals B, and A and B are both matrices. How am I going to solve for X? Well, you can't divide by matrices, but we can multiply by the inverse. So this is basically what I'm going to do. I'm going to multiply both sides by -1, A to the -1. Now, notice how if I multiply on the left side by A to the -1 here, I need to multiply by the left on A to the -1. Why? Matrix multiplication is not commutative. So I can't multiply by B times A to the -1. I need to multiply on the left. So make sure you always multiply on the left of your constant matrix or your answer matrix, however you want to call that. So A to the -1 times A is just your identity matrix, and then I'll be left with whatever A to the -1 times B is. That's going to give your answer for X. So let's actually try a few examples of this. So I have -3x plus 4y equals 5, and 2x minus y equals -10. So I have written out my answer matrix here, and there's my A and there's my B. So what I need to now do is find the inverse matrix for A. So let's find the inverse matrix for A. So if you remember, it was 1 over whatever the determinant was. So let's find the determinant. -3 times -1 is a +3. And 2 times 4 is 8. So my determinant looks like it's going to be -5, right? Then we're going to flip-flop our A and D around and change the sign of those two. There we go. So my inverse, if I distribute that -1/5 in, looks like I'm going to get a +1/5, +4/5, a +2/5, and a +3/5. Oh, the joys of fractions. So now, what I now need to do is multiply by that on the left of both sides. So this side I need to multiply by 1/5, and 4/5, and 2/5, and 3/5. Now, this is going to cross off. That's going to be gone. It's going to give me the identity matrix, right? I'm going to be left with x and y. Now, we need to multiply this one by that. So let's write it off to the side here. Because remember, we need to put our inverse on the left of our answer matrix, or the constant matrix. There we go. Now let's multiply. So I have 1/5 times 5, which is 1. And, oh, hold on. What kind of matrix are we going to get? 2 by 2, 2 by 1. Those are good. So I'm going to get a 2 by 1 answer. There we go. So 1/5 times 5 is 1. 4/5 times -10, -8. Right? Because that'd be -40 divided by 5. Yeah, -8. So let's do the rest here. I gotta multiply, so that was my first row by my column. So second row by my first column. So 2/5 times 5 is 2. And 3/5 times -10, -30 over 5, so -6. So my answers, 1 plus -8 is -7, and 2 plus -6 is -4. So my variable matrix, because this was left over, right? So I know x equals -7 and y equals -4. Not too bad, right? Once you get your inverse matrix, which you can find on your calculator as well. That way you don't have to actually do all the work. You can multiply as well on your calculator. Let's try another one. So example 3. I have this wonderful matrix right here. Let's write out our coefficient matrix. So I got 7, 3, 14, -4. Then I have my x and my y here. And my answer. There we go. So let's find the inverse of A. So let's find the determinant, right? So 7 times -4 is a -28 minus 14 times 3, which is 42. So I'll have 1 over -70, it looks like. That's a big scalar. So 1 over -70. Let's write our new matrix. So flip-flop A and D around. Change the signs. There we go. So it looks like some stuff's going to kind of cancel itself out and kind of simplify, right? Because 1 over -70 times -4 is going to give me 2 over 35, because I can take a 2 out of the top and the bottom. 3 over 70 does not simplify, but my negatives are going to cancel out. 14 over 70 does cancel down to 1/5. And 7 over 70, well, that's -1/10. So now, we need to multiply that by, on the left of both our coefficient matrix and our answer matrix. So this is going to give me the identity, so this is gone. Now I'm left with x, y equals, and let's multiply by our inverse. By 11 and 2. Alright, so 2 times 35 times 11. Well, that's going to be 22 35ths, right? Looks like we're going to get another 2 by 1. So I'm going to get 22 35ths plus 6 70ths. Right? And then 1/5 times 11 is 11/5, and -1/5. Whoops. Alright, let's simplify. So I know I'm going to get, don't have a common denominator. So that's 70 and 44. So I'm going to get 50 over 70, so basically 5 over 7, right? And then 10 over 5, which is just simple old 2. So I get x equals 5/7 and y equals 2. Which would be a lot easier than getting 5/7 and having to plug it back in. So these are actually not too bad. So let's try a 3 by 3. Let's write our coefficient matrix. 2, 3, 1, 3, 3, 1, 2, 4, 1. Now, my variable matrix is going to have an x, a y, and a z this time, because we have all 3 of our variables. Now, remember, our inverse matrix for a 3 by 3, we get to use our calculator. So I quickly did that on my calculator, and I got -1, 1, 0, -1, 0, 1, and 6, -2, -3. So now, assume, if we would multiply by our inverse matrix, right? These are going to cancel out. We'll be left with x, y, and z. And then let's multiply these two together. And it looks like I'm going to get a 3 by 1 matrix, right? So negative 1 times a negative 1 is a positive 1. 1 times 1 is 1. 0 times negative 2 is 0. Okay. Negative 1 times negative 1 is a 1. Plus 0 minus 2. Negative 6. Negative 2. Positive 6. So it looks like my answers for my system are 2, negative 1, and negative 2. So x equals 2, y equals negative 1, and z equals negative 2. I personally feel this is a lot faster than having to pair them up and multiply, and you lost a sign. I think this is a lot quicker than that, because your calculator can easily do this as well. Let's try it again. So I have my coefficient matrix, negative 1, 3, 5, 2, 1, and I don't have a z. But if I don't have z, let's just assume that's a 0, right? 0z would give me 0, so it's not even there. Always watch out for that. Then I got negative 9, negative 8, negative 4, x, y, z, negative 15, 1, and 12. There we go. So I used my handy-dandy graphing calculator, and I was able to find my inverse matrix of 4/7, 4, 5/7, negative 8/7, negative 7, negative 10/7, 1, 5, and 1. Couldn't imagine even doing that in my head. Holy buckets. So this multiplied by a to the negative 1, going to cancel that out. Left with x, y, and z. Now let's multiply that coefficient matrix, or my new inverse matrix, by my answer matrix. This one might be some hard multiplication though. Holy. Okay. 4/7 times negative 15, that is negative 60/7, which I don't think cancels down at all. 4 times negative 15 is a negative 60. And then 5 times 15 would be 75, so negative 75/7. Alright. Negative 8/7 times negative 15 would give us (120/70). Negative 7 times 1 is negative 7. Wonderful. Negative 10 times 12 is a negative 120/7. And then I got negative 15, 5, and 12. Almost got it. So it looks like these are going to be adding. Now, I did some quick addition in my head and on my calculator. Who am I kidding? Not in my head. I did it on my calculator. And I got, for the top here, I have 4. Middle one here, I got negative 7. Now I noticed those two are canceling out. And then the bottom here, 3, negative 3, positive 2 for my x, y, and z. So x equals 4, y equals negative 7, and z equals 2 for my final answer. Now, your calculator, graphing calculator, can multiply this out. I will show you how to quickly do that. I believe we looked at it, but I will show you again if you need any help. And that way, this is not going to be, can you multiply, it's can you find x, y, and z for me. And that's the end of this video. See you later, Sabers!